right, we're now recording. This is IA 101, deep dive into batch process or batch manufacturing. And batch was introduced already, so this isn't meant as the introductory presentation on it. It's meant as a deep dive. The idea is that batch can be both a manufacturing process used for a batch of machines, like 5 machines that are identical, or a batch of, say, potato chips in a giant vat that's cooked and then put into a line to get seasoned and then packaged. Or it could be a batch of pharmaceutical material, say a precursor for a drug, or even a finished drug goes through a batch in a reactor where materials are added, it gets mixed up, cooked, or just let to react for a while, and then gets packaged off. So batch, we're going to use a definition of batch out of Wikipedia, which I think is pretty good. A method of manufacturing where products are made as specified groups or amounts within a time frame. So this could be a range of different products. Food, pharma, chemical are more traditionally seen as batch, whereas some manufacturing lines like machine construction are also batched. So let's talk about how this batch really works. And we're going to share the screen on the slideshow. And so the batch framework, this is sort of what goes into a batch. The batch process is the stuff that we're going to dive into. But before we dive into what the batch process works, I'm going to take a step back and we're going to talk about all the data, all the things that go into a batch process and come out of a batch process. So one of the first bits of data that we have to worry about are the materials. You've got a set of ingredients. If you're talking about food products or pharma products, you've got a list of parts, a bill of materials that might go into a production line, like a group of machinery. So you've got the materials list. Those are all the ingredients, the content that into it. You also have upstream processes. You might have energy flow. You might have steam. You might have a continuous flow of some sort of material that's used in process or helps as part of the process. And so you've got upstream process steps. We also have recipe data. So someone you've got to store that. We talked about that on Tuesday as being a system called an MES, a manufacturing execution system that stores recipe data or recipes and data as well, because there's a lot of data that's associated with materials that might need to be stored. And then lastly, we need to think about the real world conditions. All of that existing environment, how hot is the existing tank? You know, what are all the existing settings in the equipment? You know, how was the equipment cleaned? One very important thing in the pharmaceutical world is recording the cleaning of the equipment and then storing up that equipment clean specifications along with whatever equipment's used. So coming out of that batch framework, we've obviously have finished products or products that need further steps. We have scrap and byproducts that can come out of the batch process. We have the data, which is probably, probably one of the most important things we're talking about so far. Obviously, the finished product is probably most important, but in many cases, you can't sell that finished product or use that finished product unless you have the data. And the data comes into 2 flavors. We've got the batch data, and then there's additional layers of data that might have to do with regulatory requirements. I'm calling that validation data. So I'm going to go out of that screen and we're going to share this presentation again. So let's talk about the data itself. The primary thing is your batch record. The batch record is where all the data goes. And I'm going to be editing this as we go. Let's change the color of this to something a little bit more golden, there's the batch record. That is your objective in any kind of batch system, is to store the data in a record that can then be accessed later on. This is true whether you're making potato chips. It's true whether you're making Advil, Viagra, anything. You need to have your data stored for that batch record. It's even true if you're making refrigerators. You want to store all the data associated with who, when, and how, all the parts that were used to produce that refrigerator. Because what if you have some refrigerators start to show up not working right? Well, then you want to go back to that batch record and chase down the reason for why they're not working right. And so you can deal with the warranty issue. This is true for cars as well. So all these things go into that. Some of the early information we already talked about is the recipe and the ingredient data. Each one of those ingredients is going to have some tracking data associated with it as well. Where did it come from? What was the vendor? Was it produced in a different plant? What batch did it come from, if any? You know, all the information associated with how you purchased it, where it came from, how it was shipped, how long it's been sitting around. Does it have any expiration date associated with it? Is it like flour and go stale? Is there analysis done on it? Say flour, all flour that's used in Hershey, that flour is allowed to have a certain amount of mouse droppings in the flour. And so they do a test on the flour to check to see how much mouse droppings are in the flour. And if it drops below that threshold, then they can use it. If it goes above that threshold, then they have to not use that flour. And so all that analysis data that's out there has to be used before they make a decision about what goes into your candy bar or your bread or whatever product they're trying to make. So that's pretty important stuff. The equipment that you selected, we talked about that. The personnel who are running that operation also needs to get recorded. All the current conditions, that's a sensor data. All that is a precursor information leading into the batch process. So let me insert a little arrow in here. Where's my arrows? There's my arrows. So it's precursor data. Let's use a different arrow color. Let's make it black. I think that's a good arrow color. And this is all precursor data. Now, once you start running your manufacturing batch, there's another set of data that needs to be collected. For instance, a lot of times, a process, especially in the food industry, you might have recipe adjustments that are made after the initial recipe selection. And that could be based on a number of factors. The humidity, it could be based on some analysis. Right? And there's during the batch manufacturing process analysis, and then there's post batch manufacturing analysis. So all this can be added in the middle of the manufacturing process. So that's going in there as well. And then coming out the back end, that finished product also has analysis, checking to see if it's quality, is it meeting specifications? If you're talking about potato chips, they have to be the right kind of color. I'm assuming they have to be the right kind of oil content. I don't know what other, they might need to be the right temperature coming out of the fryer. I don't know what else they use for analysis. I'm just guessing here. I'll ask in my questions later on from our UTS guys what they know. But all that post-batch process analysis needs to be stored in this data as well. So it's absolutely critical. So what I'm doing here is I'm just giving you guys kind of a list of the data record. So then you might ask me, where do I get this data? That is the part where you guys come in. Where does data come in? Oh, I forgot to mention, data actually has to flow along with batches, because I might have 2 or 3 steps that are called precursors, sort of batches of ingredients that end up in a final product eventually. So all of your batch data needs to flow down so that your final product is linked to the batches of any precursors, any kind of premix. Like for instance, if you premix your spice batch needs to be linked to the finished batch of packaged product that goes out the door, so that if you find a problem with the spicing, you can go back to that batch and then pull all the finished product batches that had that particular batch of spice in it. So that's an example of batch data connections. But the thing that where you guys come in is sensors and automation. The sensors that are throughout our manufacturing process, they are hooked to our PLCs, hooked to PCs. Sometimes they're standalone sensors that just sit out there on the internet and send bursts of data to some sort of manufacturing system that'll collect that data. All of the information that's available for the batch could be used for that batch process. And so, it really depends on the kind of a system we're talking about here. Let's just go through the list. You have PLC. We'll call that machine control. Within a PLC, you could have direct control sensors. For instance, if you are monitoring the temperature of your fry tank, you're cooking your chips to a particular temperature, then that fry temperature becomes a data point that you store in your record. So it's very important to have an accurate stored temperature of the actual fryer, for instance. So we'll call that direct control sensors. So they might be used in control loops. You're also going to have quality sensors. And these quality sensors might be used for alerts or line control. Like if for instance, you find that there is a classic one is you're checking to make sure no bits of metal made it into a finished product. And so you have these sensors in there to check for even a tiny fragment of steel that might have fallen out of a machine, and you're going to kick them off the line if they do. So you would also want to store that data. You might have a quality alert that's checking the color of a chip. You might have a quality alert that's looking at how, based on a camera, how a cap is positioned. And if it's not positioned correctly, if it's not screwed down tightly, that camera will trigger the PLC to kick that product off the line. So you've got a lot of different kind of quality sensors built into your machine control. The third category is, I'm just going to call it we'll call it recipe, start, stop, and duration. I guess that and start kind of recipe information, like when did that batch start? When do we start cooking it? And then we also might have material. In other words, is there a weigh scale that a raw ingredient went onto before it was put into the batch process? So you might have actual material usage data that comes straight from the PLC as well. So recipe, actual start and stop time, material usage data, all of these you can pull from your PLC, from your machine control system. And those are all sensors that you guys are going to be learning about in this course. Another area that's connected, I'll call it shop floor data collection. So a lot of times people will put standalone sensors out onto the floor to collect any number of things: temperatures, humidity, particulate. For instance, in a pharmaceutical process, a lot of times you're going to have what's called a clean room, or a room that's specifically designed to have very, very few particles in that room. You want it to get as perfectly clean as possible. And they make it so that the air handling for that system has this air pressure, so that when you open up the door to that room, the air is always moving out of the room so that no particles blow into the room. And a lot of times you're going to have an airlock. You're going to have huge requirements around personnel putting on bunny suits and wrapping up their hair and gloved and booties and the whole 9 yards. And they're going to go in there and be totally particle free. So what they do is they have these little standalone sensors inside the room and inside the airlock sometimes that do nothing but check the particulate level in those areas to make sure that they're maintaining their clean room status. We also have HVAC data, how much fresh air is being allowed into your lab. I don't know if you know this, but most industrial buildings have very limited fresh air let into that building. You might only have a 5% or 10% fresh air per cycle let into that building, which means mostly you're breathing very kind of very stale air that's been cycling inside that office building for years. And that's how a lot of office buildings get mold and other things that can go on and go wrong with them. However, if you're talking about a pharmaceutical facility or other facilities, they recirculate, or labs have generally higher quantity of fresh air being brought in, and they have a higher quantity of this makeup air, this new fresh air being brought in to keep the air cleaner, to have a less buildup of chemical odors, that sort of thing. So your HVAC data is very, very important, which also includes temperature and humidity, but it might include damper positions, it might include makeup air quantities, any number of things like that. And there's a third category. I'm going to call it, I'll call it portable sensors. A lot of times, operators go around and test environment conditions using a handheld portable sensor. So I'm sure there's other categories of sensors in automation, but I'm going to stop there. So the last category are sensors associated with MES systems, and this would include all the manufacturing, batch, basically anything that's associated with the MES system would be collecting data from other sources, but so it doesn't really have its own sensors. Manufacturing execution systems would be collecting batch data and storing batch data. So an MES system is kind of where all this data is final stored, and usually set up as the point of reporting, so that a single point of reporting for all the different sets of data collected from the shop floor or the PLCs. So that is my somewhat long-winded deep dive on batch. I'm going to Stop recording.